Quotient cluster is looking at the role of marine renewable energy in the future energy mix. So we're interested in how we can generate electricity from the waves and the tides. We're interested in how we can quantify the resource, so how we can go out in vessels like this to measure the resource, and how we can use computer simulations to simulate the resource and how the resource will vary into the future. And also ways that we can minimise the impact on the environment of extracting energy from the oceans. And within our cluster, we're interested in how the resource might vary in the future as a result of climate change. For example, changes in future weather patterns, and also sea level rise, how this would influence the resource. The Quotient cluster is led by Bangor University, but we work in collaboration with researchers at Cardiff University and Swansea University. At Bangor, we're more experienced in looking at the natural environment, and Cardiff and Swansea are more interested in the machinery, so the actual devices which would go into the water.
Part of my work is to make computer models that simulate waves and tides. In this example, I'm running a computer model that simulates wave height for the North Atlantic. Here's the UK. And these orange colours mean very large waves, and the blue colours mean almost no wave height at all. And this is running in time, so every second you can see here equates to 1 day in the computer model simulation. And this runs for a year, so as you can see in this example, we have the average wave height for the year, and the dark blue colours show large wave heights, and yellows show small wave heights. So this can help locate regions that are best for wave energy.
The biggest challenges are the sort of extreme nature of the oceanographic environment. So the impact of turbulent fluctuations on devices, and also quantifying the resource over very long timescales. Another example of that is looking at interaction of waves and currents, because each of them influences the other resource.
The work that we're doing in relation to Bangor is Bangor are concentrating more on the resource and we concentrate more on the devices. What we're looking at here is some data from the northwest demo zone of the coast of Anglesey, and what you can see here is we've got essentially the strength of the turbulence over roughly a 2-month period, going from about September to November 2014. And going from near the bed to near the surface in that direction. What we see is that it's getting a lot stronger near the surface. These kind of yellow peaks here is actually picking out the fluctuations due to waves. If I bring over a plot of the waves height at the same time, the wave height almost exactly tracks the strength or the apparent strength of the turbulence. So what we suspect is that this is being driven more by waves than by turbulence, particularly near the ocean surface. And that's important for developers of tidal turbines because they don't want their turbines to be experiencing lots of fluctuating loads. What we might find is that rather than being worried about turbulence, tidal developers should be more worried about waves as the bigger contribution to fatigue and fluctuating loads.
So another part of our research is to look at the resource of the tides, to see where best to build lagoons that can produce constant electricity. So in this example here, the model shows the tide travelling up the Irish Sea. So the red colours show high tide and the blue colours show low tide. The tide travels up the Irish Sea in such a way that if you built a tidal lagoon in the Bristol Channel and another tidal lagoon in Liverpool Bay, you could generate constant electricity from the tide.
And the ocean represents a vast resource. There's huge global potential for generating electricity from waves and tides. And in fact, the UK and Wales in particular are very well placed to exploit this form of electricity generation.